what we're going to try to do here is emulate in every way possible what they do in example 5. So just going to run through stuff probably pretty slowly, but we'll see what we can do. Here's the problem I want to look at. It's up here. It says how many tickets are sold at an event depend on the ticket price. One particular annual event knows that the profit P in dollars is related to the price P of tickets in dollars in the following way. P equals f of x equals minus 15x squared plus 600x plus 60. It says we look at it algebraically and graphically and try to interpret everything. Well, I'm going to look at it a little bit algebraically first, and then we'll look at it graphically, and then we'll see what we can do. So here we have it. The very first thing I want to do is find the y-intercept because we know that's very important. So I'm just going to write down y-intercept. Now remembering, this is where it hits the y-axis. Strangely enough, the equation of the y-axis is x equals 0. So you find the y-intercept by plugging in x equals 0, and we get p of 0 equals 60. That's kind of weird. This says if we charge $0 for this event, we're still going to make a profit of $60. So I think people are contributing somewhere. But that's the very first thing to do, is find the point and interpret it. The next important point that we can find algebraically is the x-intercept. There should be 2, usually if this is a quadratic function. Remembering that the equation of the x-axis is y equals 0, we find the x-intercepts by setting y equal to 0. So I'm just going to write down y. Minus 15x squared plus 600 plus x plus 60. I'm going to set it equal to 0, like that. The very first thing we want to do when we factor is take out what stuff have in common. Now the terms all have a minus 15 in them. I could pull out a 15. It makes my life easier if I pull out a minus 15. So I pull out a minus 15, I get x squared, I get minus 40x, and I get minus 4 equals 0. Now I'm multiplying two things together to get 0. So either minus 15 is 0, which, it's not, or x squared minus 4x minus 4 equals 0. So I need to solve that equals 0. Let's put a little equal 0 here, just so I have something. It doesn't factor, so we have to use the quadratic formula. So here we go, quadratic formula. I'm going to get x equals 40 plus or minus the square root of 40 squared, which is 1600, plus 4 squared. No, it's 4 times 4, which is 16. So I'm going to get 16 right here, all over 2. Now when I put that into my calculator, and seriously, I have my calculator right here, I get that this is 40.09 something, and I'm just going to put 1 and underline so we can see that we rounded correctly, and negative 0.1, which by the way makes no sense because you can't charge a negative price for tickets. So what does this say? Well, let's look at the graph first, and then we'll try to interpret it. Then we'll use the graph again, and then we'll come back. So I'm going to go over to the calculator. I'm going over to Desmos. And you can see in Desmos, I put in our function. Hooray! And holy crap, that's a miserable looking graph. I know this is a parabola. I do know, by the way, that one of the x-intercepts is at 40, right? So I'm going to start zooming out. I could try to start changing something. I just want to see a top. I'm looking at the top. I see red. I see red. Oh, I can see the bottom coming down. You see the bottom coming down right here? Well, how about if we do this? I'm just going to go change the wrench for the moment and make the x. I know it doesn't go to the left at all. I'm going to put a negative 1 over there. I'm going to put, say, 45 right there, and just see what it does in my graph. Let's shut off the wrench again, and I can see it's going up over here. I can see it coming down over here. I'm going to start zooming out again. At least this looks more reasonable than before. I'm going to slide down the graph a little bit. Oh gosh, we're almost there. There it is. Yay. Now what I'm going to do, there's my graph. I'm going to go back to the wrench. I don't really want any negative x values. They're supposed to be ticket prices. So I'm just going to go change that to negative 1. I can't have negative profit either, so I'm only going to go as far right as, say, 45. I suppose I don't have to go quite even that far. 45. And there we have a picture. That's a lovely picture. Now, how are we going to use this picture? Well, we can see, we knew at the beginning that if we plug in 0, we got 60. So the height of this dot way over here is 60. Yes. Way over here at $40.10, right? If we charge $40.10, that's way over here, we can see that we're not going to probably get any customers and we're not going to make any profit. That's how I interpret that. Now the problem is we're trying to find the maximum profit. Well, how do I find the maximum profit? I need to go to the high point on the graph. So I'm going to go way up here to the high point on the graph, and I can see that that happens when x equals 20. I'm just going to click on that, and hopefully I'll get something. Yeah. Oop, there it is. Yay! I see that I get 20. When I charge $20, I make a profit of $60.60, and that's as much as I make. I guess what I'll do over here is just put a little note to myself so I don't forget it. And I'll say that P of 0, P of 20 equals 60.60, and that was the high point. And what does that mean? That means, just in terms of everything we're doing, don't charge less than 0, not even possible. Don't charge more than $40.10, you won't make any profit. And if you really want to make the most profit, you're going to go up to the high point, that's actually called a vertex on a parabola, and charge $20 a ticket, because that way you'll make the most profit. That's all we want to do is just analyze that function, and we're done.